The next topic we'll be covering are containers in Cosmos DB. Azure Cosmos containers are useful for scalability in Azure Cosmos DB, both in terms of storage and throughput. They are beneficial when you need a different set of configurations for each of your Azure Cosmos DBs because they allow you to customize each container individually. Some applications may require robust write capabilities for logging, while others prioritize reading due to data access needs. With Cosmos DB containers, each application could have a customized container that meets its demands, balancing performance and cost. Azure Cosmos Container has some container-specific properties, and those properties, which can be system-generated or user-configurable, vary according on the use API. An Azure Cosmos Container has a set of system-defined properties. Depending on which API you use, some properties might not be directly exposed. The table lists various system-defined properties in Cosmos DB and indicates which ones are system-generated versus user-configurable. Additionally, it also denotes which properties are used by different APIs for NoSQL, Cassandra, MongoDB, Gremlin, and Table. RID type system-generated purpose acts as a unique identifier for a container, supported by only the API for NoSQL. ETag type system-generated purpose utilized for optimistic concurrency control. It ensures that only one client can change an item in the database at a time, supported by only the API for NoSQL. TS type system-generated purpose represents the timestamp when the container was last updated, supported by only the API for NoSQL. Self-type system-generated purpose provides an addressable URI of the container. It's essentially a unique reference or link to the container, supported by only the API for NoSQL. ID type user-configurable purpose denotes the name of the container, supported by all the APIs listed. There are many more properties, but we won't be able to list them all here.